We're going to talk about the sum of the interior angles of a polygon. So in the picture that we see here, we have a polygon that has 1, 2, 3, 4, 5, 6 sides, and a 6-sided polygon is called a hexagon. They are asking us what is the minimum number of triangles needed to construct this hexagon. So let's pick any one vertex, which is just a corner where 2 lines meet, and let's draw as many triangles as we can. Well, if we go directly to the vertex across, we do not form a triangle, we just form that line segment. So we have to move over and go to this vertex, and there's the first triangle. We can see we have 3 sides for a triangle. Then when we connect to this vertex, there's the second triangle. Again, there are 3 sides for a second triangle. And then when we connect to this vertex, there's the third triangle. And then when we connect to this vertex here, we don't have another triangle with just those 2 vertices, but we do have this 4th triangle that's left on the right-hand side. So you can see where there are 4 separate triangles. 1, 2, 3, and 4. 4 triangles when we created line segments through the hexagon from this vertex to other vertices. So this has 4 triangles. There's a pattern, and no matter what's the number of sides, so here we had a hexagon which was 6 sides, the number of triangles that can be formed is always 2 less. So that leads us to a formula to be able to figure out what all the angles inside this hexagon add up to. So that's what we're calling the sum. Sum means addition. Interior angles, the inside angles of a polygon. And a polygon is just the name we use in general. When we're more specific, we call it something that refers to how many sides it has. We know that a triangle has 180 degrees. We learned that previously, that a triangle has 180 degrees when you add up the 3 sides. So again, we know that if we have one triangle, something plus something has to equal 180 degrees. Well, here we have 4 triangles, so we could multiply 4 times 180 to figure out the sum of the interior angles, 1, 2, 3, 4, 5, 6, the sum of those 6 interior angles in that hexagon. And like we said, no matter the number of sides, so if we let n represent the number of sides, we need to take away 2 from n and then multiply by 180 degrees to get the sum of the interior angles of a polygon. So n minus 2 represents how many triangles can be constructed. So let's say we had a square. It has 4 sides. 4 minus 2 equals 2, which means we can construct 2 triangles. And 2 times 180 equals 360, which means the 4 sides add up to 360 degrees, which should make sense because a square has 4 right angles and 4 90-degree angles. 4 times 90 is 360. So you definitely want to make note of this formula. for finding the sum of the interior angles of a polygon. And you could also make note of n minus 2, because that's what we use to figure out the number of triangles that can be constructed in an n-sided polygon. So a 6-sided polygon, 6 minus 2 is 4. 4 triangles could be constructed. In a 10-sided polygon, we call that a decagon. 10 minus 2 is 8. 8 triangles would be constructed to make up the entire decagon. Here are 2 more examples. We've got what is the sum of the measures of the interior angles of this polygon. To answer this question, the first thing I'm going to do is count the sides. 1, 2, 3, 4, 5. So n equals 5. N represents the number of sides. N minus 2, or 5 minus 2, is equal to 3, which tells me that if I started at one vertex, I could create 1, 2, 3 triangles. 3 times 180 is equal to 540 degrees. So the answer to this question is 540 degrees. The 5 angles inside this pentagon because it has 5 sides, add up to 540 degrees. And one more example, if we have 2 triangles we're required to construct the figure below. What is the sum of the measures of the interior angles of this figure? So let's just count the sides of this figure. 1, 2, 3, 4. N equals 4. 4 sides minus 2 is 2. So there's the 2 triangles. Times 180 is 360. So this figure has a sum of 360 when you add all 4 angles. So again, n minus 2 times 180 equals the sum of the interior angle measurements. Thank you.